So you're all welcome to our class now. And today we want to practice yet another question on investment appraisal. Yeah. So let's go through the facts of the question requirements. The question requirements. Calculate the equivalent annual cost of the 3-year and 4-year replacement intervals for the BEAST and advise the C which replacement interval to adopt. Yeah, so that's something that we've looked at before. Discuss why replacement interval decision should be based upon equivalent annual cost method. Okay. Discuss why discounted cash flow methods of investment appraisal are considered superior to non-discounted cash flow methods. This is a very good question. One of the most important parts of this question, I think it's C and D. C and B. Okay. Good. Yes, please. Somebody's hand is up.
I didn't receive that question personally because it's not in the group. So I'm not sure if you can probably resend it.
What was the one last time? Did you get the one we sent last time?
Yes, the one you sent last time I did.
How many were there?
But with this one, there were 2, if I'm not mistaken.
The second one must be this one.
I also don't receive these questions. I asked for some copies, but I never get any. So I'm kindly asking if you could be sending me so that I can practice before the class.
Who is that one speaking, please? Let me know the next second person speaking.
Olivia.
Okay. So did we put you on the group? Not yet.
No, I'm not in the group. So it gets to be very hard to follow through when I haven't even gone through the question and then the explanations when I log in.
Okay, no, I'll chat with you after class. So we can add you to the group.
So I've checked the group and there's nothing. The last question was on the lease. FM revision question, lease or buy.
Lease or buy. Okay, let me just check. It's the same forum I'm checking on too. Okay. Okay, so send me, there's Katie, do I have your number? Katie, do I have your number?
Yes, you do. Yes. Maybe I can send you a WhatsApp.
Yeah, can send me a message. Send me a message so that I can.
I've done that.
Yeah. Okay, so let's. So the question is here. So C company is a construction company, uses large earth-moving vehicle called the BEAST to prepare foundations for its buildings. It needs to decide whether the cheapest replacement interval for the BEAST is 3 or 4 years. C purchases the BEAST from a manufacturer at 800, payable 1 year after delivery. Now, I think Jesse had asked me a question last time. That is the payment always in year 1. Remember, Jesse, you had asked a question. It's always in year 0. We have a situation here. Have you noticed? 800 payable 1 year after delivery. its resale value will fall by 40% of the purchase price at the end of its first year of operation. The resale value then reduced by 25% of its previous year's resale value for each further year of operation. You're playing around with numbers. Have you noticed this question? Yes, maintenance costs are 20,000. Yearly maintenance costs are 20,000 at the end of its first year. Notice that, rising by 5% per year. Maintenance must be provided in the year of sale. Yearly fuel cost is 28 in the first year, rising 5,000 for each X-ray it is operated. There's a lot of numbers in this question. If the beast is operated beyond 3 years, remember the 3 or 4 year cycle, it is subject to a government safety and carbon emissions test. The test would be paid for and would take place at the beginning of the 4th year of operation. Correction of any faults discovered by this test is mandatory. There's 80% chance that the test and remedial work will cost C 50,000 and 20% chance it will cost 120. There's a bit of risk and uncertainty here. We're not certain over how much this will be. And I'm sure all of you can remember what method you are likely to use to resolve this uncertainty, isn't it? And the cost of capital is 8%. So it's a question with figures, and we are going to follow through on these figures now. So let's put our heads together. Let's put our heads together. I'm sure if we put our heads together, this question cannot be complicated for us. What do you think? If we put our heads together, what's going to happen? We'll demolish the question, Yeah, let's demolish the question. Let's demolish the question together. It's a matter of us following the figures and following the instructions given about the figures. So we need to follow the instructions. Okay, I hope my screen is visible out there. Can I just get the confirmation?
Yes, it is.
Excellent, well done. Okay, so now let's use the usual table to do the arrangement of our figures. Yeah, so let's use the usual table. I'm sure now you are familiar with the table method, aren't you? We are familiar with the table method. So let's do a cycle, 3-year cycle. Let's do a 3-year cycle. Everybody, we start with a 3-year cycle so that we check which cycle is the cheapest. We go 0, 1, 2, and 3. What is the purchase cost? What is the purchase cost?
800,000.
Good, 800,000. And we sell it at the end for how much?
But they say it's payable 1 year after delivery.
1 year after delivery. And we get how much out of it? When we sell it end of year 3. Let us follow through now. If your value is 40% of the purchase price at the end of its first year of operation, the resale value will then reduce by 25% of its previous year's resale value for each further year. So let's go. What will it be? The resale value. After 1 year, it will drop by what? So I take the 800. They say it will drop by what after 1 year?
By 40%.
It will drop by 40%. Okay.
Yes, sir.
All right. By 40%. So it means what will remain in only what percentage? If it drops by 40, what will remain will only be what?
60%.
60% is what will remain. And after that, so that is year one. So after year one, 40% is gone. After year two, what percentage will go? The first year I've taken out the 40%. From year two, what should I remove?
25%.
So it means that what will remain for me will be that. And the third year again, that. Is that okay? Let's do another working here so that we don't leave anyone behind.
Sorry, sir, I've lost there.
Let's do another working. So the asset cost is 800.
Hmm?
In year one, what are we going to lose? Times 800. So let us go that times 0.4. That one is gone. In year two, how much will go?
With 25
25%.
Of what?
of the
25%
Let's read it.
800
of the 60%.
Aha, okay, fine. So then a good presentation then should be, I do this. Of course, it's longer, but let's do it. So a good presentation is, let me do this. How is that? How is that one? You like that presentation?
Yeah, it is. It's easier to follow. Through.
I noticed, so. I noticed so that we're going to land into a problem with the other shortcut. I noticed that the other shortcut was going to land us in problems. Not so. Not so. This one is better. Have we arrived at the same answer?
Yes.
Good. Okay. Are we okay now? Let's go to the next one. Yearly maintenance costs are 20,000 at the end of its first year, rising by 5. So maintenance cost. What are the maintenance costs? Every year it's what? What of there, what will it be? What of there, what will it be?
It will be 21.
It should increase by what percentage?
By 5%,
By
if I'm not
5%.
mistaken.
How do I increase the figure by 5%? I multiply by 1.05, isn't it?
Yes.
Yes,
Good.
giving us 21.
Okay. Yeah. Now, since these all these, okay, this is a cost, fine. Times 1.05. Okay. 21. Have I done 1.5? 1.05. Okay. So the figures are, so we do this. Yeah, that's much better. Another cost, is there any other cost? Is there any other cost?
We have fuel cost.
Excellent. We have fuel cost. What have they told us about fuel cost? In the first year, it will be how much?
Fuel cost.
In the first year, the fuel cost says your fuel costs are 28 in the first year and rising by 5% for each extra year it is operated.
So there it comes to how much?
So the first year it's 28.
Yes.
Second year it's 33.
Yes.
The third year it's 38.
Here we go. Okay. Interesting question. This is a minus. You know, this is a minus. It's a cost. This one is a cost. What's the net position? So we go.
I have a question.
Go ahead.
On the 33, the first one was 28, quite right. And then we're multiplying by 1.05, isn't it?
It has an absolute figure has been given. Just check the question. It says a 5,000.
Oh.
Have you seen it? Have you seen it?
Yes, I've seen it. Yes, I've seen it.
Good. There we go. Here there was nothing. Here it's supposed to be 1. Here. Okay. Present values?
Sir,
Yes, sir.
I think the
Yeah.
resale value of 270 should be an inflow.
Yes, it is an inflow. It's just been affected by I picked it up from there.
Okay.
You're right. It's the formula with which he changed it. Excellent. You are right. Okay.
Six.
Let's go. Let's compare figures. Let's compare notes. I'm happy when people are talking like this. You know, with this online, you can never know that you are just talking to yourself. But when people are talking like this, then I know I'm not alone. When people are commenting, then I know that I'm not alone. Okay, so this is the total cost. If we decide to run the vehicle for how long, people? For 3 years,
For 3 years.
Good. Now, the other possibility is running for 4 years. When running for 4 years, what are the issues that will arise? If the vehicle is operated beyond 3 years, it is subject to a government safety and carbon emission test. The test will be paid for and will take place at the beginning of the 4th year of operation. Correction of any fault discovered by this test is mandatory. There's 80% chance that the test and module work will cost 50 and 20 will cost 120. There's uncertainty or risk and uncertainty relating to each one? To the correction cost. How do we resolve it? What method of risk and uncertainty has presented itself here? What method of incorporating risk and uncertainty has clearly presented itself here? Can we have a comment, please? Which method are we going to use? Could somebody please help us? I can hear a correct answer there coming.
So,
yes, sir.
Are we not expected to use expected values?
Yes, that's the answer. No, just answer it that in this case, because of the nature of information given, we're going to use a method called expected value, an average. Yes, you are right. That's an average. So we need to include a line there for the correction cost. Okay. Correction cost. So from the information given, this correction cost, when is it going to be paid? Can somebody?
In the 4th year.
Let's be
It
very.
will be paid in the 4th year.
Let's be very careful there. Let's be very careful there. The safety test. The safety test.
In the 1st year.
Let us be very careful there. Let's go.
At the beginning of the 4th year.
Let's read here. It says that beginning of the 4th year is what? The beginning of 4th year is what we call what? Which year is that?
The 3rd year.
End of 3rd year. You know, this question was testing that you know how to read these figures. The way we read these figures is as follows. This one is end of year 1, end of year 1, end of year 1. This is end of year 1. So the beginning of year 4 is end of year 3. So what is the cost there that you're supposed to put? Now you're supposed to calculate expected value for me. Can you get an expected value, please, for me there? Expected value. There are two possibilities. What are the figures? The costs could be what?
There's 50,000.
There's 50,000. Or what else?
And there's 120,000.
So there are two possible outcomes. What are the probabilities? This one?
8 and 20.
And this one is it? So this is the, and what you do out of this now, we calculate to get what? EV. How do you get the EV? That multiplied by that. Okay. And then we add them up. Get the point?
Okay.
So to get the expected value, we multiply that by that. Let me just make this a bit bigger. Somebody was about to ask a question. Please feel free. So there are two possible outcomes, that one and that one. And the probability which has been assigned is that one and that one. So you multiply this by that, multiply this by that, you get these figures and add them up. And this is what we're going to put where? Here. That's what you're going to put here. Resale value, what will it be? After the 3rd year, what will it be? Will it still be 270? Will it still be 270?
No.
What will it be? Have you calculated what it will be?
It will be 203. 203.
Okay. Let's go. So what we're supposed to do is we take this figure, we multiply by what?
5%.
Yes. Then we subtract. So when we say that minus that one. Have we followed all of us?
Yes.
Yep. So that's here 4 there. So 25% of 270. There we go. That's the midway. So 202.5. here. What are the fuel costs? Let's go maintenance costs. Somebody to guide the maintenance costs, I must increase it by what? Huh?
By 1.05.
Yes.
1.05.
Excellent. What of this one? We simply add the what?
A 5.
5.
A 5. So it becomes what?
43.
43. Okay. There we are. It's a nice, interesting question on a Friday. It's a nice, interesting question on a Friday, isn't it? Let me just put my figures here. Let me just make sure that everything is okay up to there. And that something there. Let's check it. Let's agree. Let's see if we agree on the figures. Are we agreeing on the figures? Are we agreeing on the figures?
Yes.
Now, as we discussed, we can't make a decision by looking at these two figures, isn't it? We need to calculate the equivalent annual cost. So remember, our formula, we say we've got a cycle. The cycle is what? The one for 3 years and 4 years. And there we've got your NPV. And there we've got the ESC. You've skipped it. There we've got what? Annuity factors.
Okay.
At what percentage? At 8%.
At 8%.
Okay, now we can calculate finally. There's hands that are up, please. We give you an opportunity to talk. The hands that are up, we give you an opportunity to talk. Let's go. This one comes from here. This one comes from there. Please, can you help me with the annuity factors? Can I be helped with annuity factors? Can you be helped with annuity factors?
Year 4 at 8%.
Year 4, let me just counter check 1 or 2.
Year 4 at 8%, it's a 3.312.
Okay, my figures are now correct. There was something wrong with my figure. No, it's correct. So that was year 4 is how much?
3.312.
Okay. What of the other one? Year 3?
Year 3 is 2.577.
Good. Equivalent annual cost. We take this figure, we divide by this one. And we do the same thing here. So now, what are we recommending? Looking at these are costs, right? What are we recommending?
The replacement should be done in year 4.
We must do every 4 years, right? Good. So this question was really testing your discounting and also following instructions. Yeah. Why do we annualize the figures? the equivalent annual cost. What's the thinking? We discussed that here, basically what we are doing is we are looking at more like two projects. One project is a 3-year project, and another one is a 4-year project. Okay, so each cycle is like a project whose time frame is different. Okay, so what the appropriate thing to do is we need to find the common terms for calculating or for comparing these. And what we do is we annualize. We express the figures in their annual equivalents. So how do we do so? We find the net present value for each cycle or each project, as it were. Then we divide not by the number of years, but then by the annuity factor for that particular time frame. So that now the figures relate to the same period of time, and we can actually do a proper comparison. Why are discounted cash flow methods better? How many discounted cash flow methods do we have? Internal rate of return and NPV. Why are they better? They take into account what? Time value of money. Secondly, do they leave any year like payback? No. They consider all the years. Thirdly, they're not based on cash flows. They're based on what? Sorry, they're not based on accounting profits. They're based on what? Cash flows. They're based on cash flows. And thirdly, these methods ensure that the wealth of the shareholders is maximized. Maximization of shareholders' wealth. So, why are the figures? Why are the discounted cash flow methods better? Number one, the time value of money is captured. Number two, all cash flows are considered. Number three, they are cash flow based. They don't use accounting profits, no, are cash flow based. And they support shareholders' wealth maximization. So these are the points that you need to use to say why discounted cash flow methods are actually better. They take into account time value of money. They don't leave any cash flows. They are also cash flow based, unlike accounting profits, which will be affected by the choice of policy. And here, these methods ensure that the wealth of the shareholders is maximized. Yes, please. There's the hand which is up. There's a hand which is up. Kate, your hand is up.
Yes, sir. Looking at the previous questions we've been doing,
Yeah.
we've been starting with the latest year. Is it because they were working backwards? That's why we started with the third year.
Come again. I've missed. Looking at the other question.
With the previous questions, we've been doing on replacement. We're starting our question from the latest year to until and then, but with this one we started with like third year and then went fourth year. Is it because we're working backwards?
Okay. What is the reason why we didn't start? It's because there were some those cash flows, because of those cash flows in year 4, you know. Year 4 cash flows. But even if we start with a 4-year period, it's okay, Bertram. Eh? I hear you very well. If you say me, I would have said with 4 years, Mr. P, then go 3 years. Absolutely not a problem. And the advantage is that you have all the answers already, you know, Bertram. Is that okay, Bertrand?
Noted, sir. Noted, sir.
Thank you, if everything has gone well. Now there's another question that I want us to try out. The group has got a lot of energy today, so we need to try. There's another question also. These are exam questions, right? So it means that they are very good. It means that they are putting you in the mood for the exam. Yeah, so let me just add a question. There are two questions that I have here. Okay. All right, let me add the questions. All right, so the questions are here. Can I get a response as whether you have received your question? Can I get a response?
From my end, I've received.
Good. What of others? Katie, have you received your question? Olivia, have you received your question?
Received, sir.
Received, eh? Good. Let's look at the question requirement together. And is my screen visible, Bertram? Bertram, is my screen visible?
Yes, it is visible, sir.
For investment decision number 1, calculate the net present value of project B. And given the capital constraint, calculate the optimum investment combination and the resulting net present value. That's an interesting one, capital rationing. The other one, for investment to explain the approach C should use to determine optimum replacement cycle for the company car fleet. This one, I'll leave it for you now. You know a lot how to do what? How to make an asset replacement decision. In relation to investment 3, describe 2 approaches for dealing with inflation and provide the reasoned recommendation as to which approach the management should follow. Now that's another interesting one, isn't it? Yeah. So let's go. Let's come now here. C is the manufacturing company has 3 investment decisions for the coming year. Number 1, investment decision number 1. 6 investment projects are being considered with the following details: initial outlay and net present value. Okay. Project B is expected to generate the following annual cash flows. Project B, they say they don't know. They want you to do what? To help us. Project B cash flows are before allowing for inflation of 4% per year for sales income and 5% for cost. C has a nominal cost of 10%. Due to management reluctance to raise new finance, capital for investment in the above project is currently restricted to 5 million. Project A, B, D, and F are all independent, but project C and E are mutually exclusive. All of the above projects are divisible and none can be delayed or repeated. Let's go. Let's do a review about the asset replacement. Not asset replacement, capital rationing. Tell me something. What did you learn about capital rationing? Let's start with what is capital rationing? I want somebody from the group to tell us, when does this problem arise of capital rationing?
When there are not enough resources.
What type of resource? Let's be specific.
When there's limited capital to invest.
Yeah, so there's insufficient capital. We don't have enough capital for investment. Okay. To invest in all the profitable projects. Like here, we can see that all these projects are what? They are what? Good. And the money, how much money do they have, these people? How much money do they have? How much money is available here?
5 million.
5 million. When you add it here, how much money is needed? Please, can you quickly add it there? How much is needed in total?
$7,525.
7,525. That's how much is needed. Okay, so there's a shortfall. Now, what are the two causes of capital rationing?
Sorry, sir, I think I'm a bit behind with the figures because I think the other phone I'm using is not clear with the what. I'm trying to zoom. I don't know which figures you're speaking.
These ones here, 1.5, 750, 1125, 18813. We add up these figures here.
Okay. The ones which are saying initial outlay?
Yes, outlay, yes.
Okay.
There are two types of capital rationing. What are those?
Hard and soft capital rationing.
What causes soft capital rationing?
They are caused by the soft capital rationing is caused by internal factors.
What of have the hard capital rationing?
External.
External. What's the situation here? What is causing capital rationing here?